Hello, my name is Blaskic, and I'm presenting on sections 1.1, 1.2, 1.3, 1.4, 2.1, and 2.2. First problem that I chose is exercise 1.6 H, namely. So this is my most painful mistake that I did. As you can see on the paper, I didn't read the problem well. So what I did is that after I read input 1, I went back to Q1 if the new input was 0, instead of going to the state that is accepted, because after reading 0 once at any point in this specific DFA, finite automata, we cannot get to the state that is not accepted. If that makes sense. So this was my most painful mistake. Problem number 2. I put this problem on just to talk a little bit about like general knowledge that I was getting when I was doing these problems, even though I knew that DFA couldn't I mean that the proof for operations of concatenation and star operation couldn't be done in the simple steps, so we introduced the NFA, and then after NFA we went to regular expressions. So after introducing non-determinism, we went to regular expressions. This is what actually this exercise actually made sense for me about everything that we learned so far in the class, and why we were talking about DFA, why we were talking about NFA, and it just shows me how beneficial it is to have one regular expression instead of NFA. So when dealing with this problem 2A, I was very proud of the knowledge that I gained, like once seeing that I actually understand the whole story behind what is happening, why are we learning about, why are we introducing NFA and regular expressions. I want to say what's happening behind the scenes. So long story short, in these particular examples, we are converting finite automata to regular expression. So what we are doing, we are ripping one state off at a time after adding accepting state and start state, and then we are ripping one at a time in order to have just regular expression, which is shown as a solution. We are using GNFA, which is basically NFA with having regular expressions on each arrow as an input to the state. So yeah, I just wanted to mention, because I brought these two examples just to say that this gave me that idea why we didn't why we were talking about DFA, and why it is why was it important to prove that DFA is equivalent to NFA, that NFA is equivalent to regular expression, and that all of them are actually representing regular language. And why is regular language important? And by doing these examples, it just shown me how that whole story makes sense actually, and how from something very abstract, something very maybe unuseful in the beginning, we came to something very, very useful, as the regular expressions seem to be. Then from problem 2b, when we are converting regular expression to NFA, we are basically showing how much more complicated are regular expression looks when it's presented as NFA. We are using the rules that we learned in section 1.3, and we are just we just started from ABB and we concatenated ABB together, then did star operation on that concatenation, and then concatenated that on A and union that with B. It's not something very complicated, but I said I wanted to bring these up just to say that I was very proud to actually like understand the story behind the scene. Problem number 3 was actually the problem that I was very proud of, because in the beginning it seemed like I have to do much harder job to figure out how to solve this problem, let's say. But then when I was doing it, when I just intuitively some ideas came across my mind, and then I was like, well, this reminds me of like I was just thinking, if 0 1 0 and 1 0 1 mean that we have the same number of occurrences of the substring 0 1 and 1 0, then I said to myself, that means that if I can prove that 0 1 0 is a regular language, then I can just concatenate a few regular languages and prove that this one described in the problem is actually also regular language. So what I did is that first I said that, as you can see, that this problem can be worded in a different way using regular expression, and then I might use the wrong wording there, but part of this problem can be worded in a different way, if that makes sense. So like this can be concatenation of the string that starts and ends with the same symbol, because only in that case number of occurrences of the given substrings would be satisfied. So what I did, I just separated like the huge string to like little substrings, and each of those substrings just have to start and end with the same symbol from the alphabet given. So as you can see, then I proved that this language is actually regular by proving that each string that starts with 0 and ends with 0, and that starts with 1 and ends with 1, is actually regular. 0 and 1 are trivially regular languages. So I said that x equals O, y equals 1 on p, so p times symbol 1, and z equals O if it starts with O, and we can see that, and this, as you can see, the for when it starts with 1, I did the same thing, similar thing, and then all three conditions are satisfied in that case. Okay, moving on, problem number 4. I found this one very interesting because it actually like it gave me like an example of like how can I, for example, how can C language see and accept comments when somebody is coding. Let's say that this is C language comments acceptor, and it just I found it very interesting that to build up something like this with DFA. I don't know why, I just find it interesting. And the regular expression that recognizes this again shows how simple it is to use regular expressions, and how uh, how how great we were to actually like be able to use them instead of using just DFA, and how great was it to actually uh, introduce non-determinism in order to prove and to do a closure of the operations that we haven't been able to close with finite automata. So we close them with non-deterministic finite automata, and that actually like how lucky we are to be able to do that in order to now work with regular expression, which is actually what makes a bit more sense and gives a lot more free space to actually do some stuff. Problem number 5. This is one of two problems that I'm most proud of. That's exercise 1.30. I had to find error in proof of O star concatenated to 1 star being a non-regular language, and I had the hardest time dealing with understanding this this part, like introduction of non-regular languages, or section 1.4. So in particular, like doing I'm sorry, my so in particular defining, like proving that some languages are not regular. So I was very proud to understand that completely doing this example. So this helped me so much this example helped me so much to introduce non-regular languages. And what I did here is that like what they did mistake by saying relating this problem to the problem to example 1.73, that is the problem that we like that you and the book presented to us in order to introduce us to non-regular languages, is O on N, 1 on N as being a non-regular language. In this case, we cannot make the same conclusion as they did, because we don't need our string to have the same numbers of zeros and ones. So it's easily proven that this is actually it's not possible to prove that this is not regular language, which means that this is actually regular language, and it's explained down there how it's like that by using x being epsilon, y being OP, and O and like p copies of O, so p times O, p concatenations, and z being 1 on 1 p times 1. So even if we have few multiple of y's, we are just gonna have more zeros than ones, but we actually don't mind that. And those are all examples that I want to present. Those are the ones that are actually kinda gave me the best idea about everything that we went over so far. And I did some other exercises in section 2, but these specifically were the ones that gave me the best idea of what we were going over so far in the class, and why we use DFA, why was it important to introduce NFA and non-determinism, why do we benefit of having a regular expression instead of just having state diagram and finite automata, how does these correlate to each other, and so far so on. So these examples in particular I chose and found the most interesting, even though some of them are very simple. I just decided for these ones to be like my go-to to talk a little bit about, and that's about it. Have a good day, and that's it for me.